Alright, and your next target for today is to be able to write an equation in standard form. And standard form is ax plus by equals c. And I have a, b, and c in red because those variables will be numbers when you see an equation in practice that is in standard form. We'll have our x and y, which represent all the points that are on the line, and a, b, and c will be integers. They'll be numbers in place of a, b, and c, and they will most always be integers. So a couple of examples here. We have several equations. We have 4 equations on the screen here. All of these equations so far are in slope-intercept form, but we want to rewrite the following equations in standard form, which is ax plus by equals c. So you'll notice the difference between slope-intercept form and standard form is that x and y are on the same side of the equation in standard form, whereas in slope-intercept form, y is all by itself on one side of the equation, y equals mx plus b. And we want to write them with integer coefficients a, b, and c. And integers are the counting numbers, the numbers that we like to work with, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all the negative numbers as well. There's no fractions, no decimals. Integers are the counting numbers. So we want to have integers there. So that's what we're going to do with these 4 equations. The first equation here, not in standard form because x and y are not on the same side. So if I'm going to change this first equation into standard form, what I am going to do is add 4x to both sides. And I just rewrote this as plus negative 6 in case you like plus negative 6 or minus 6. Doesn't really matter. These two things so far I have on the screen are exactly the same. So now I'm going to add 4x to both sides because I want to get x and y on the same side. And if I want these minus 4x's to go away, I have to add 4x. Negative 4x plus 4x is 0. And what I do to one side, I have to do to the other side. So I add 4x to the left-hand side and the right-hand side, and I get 4x plus y, it's the positive 4x, plus a y, equals negative 6. The negative 6 is right here, and now this equation is in standard form. We have x and y on the same side of the equation, and we have a constant number on the right side. And then the coefficients here are 4, that's an integer. The coefficient here is 1, because there's no number there, that's an integer, and then negative 6. So this is now in standard form, and these two equations are the same. They're just written in different ways. One's in slope-intercept form, and one is in standard form. Number 2, we have y equals 9x. Once again, not in standard form because x and y are not on the same side of the equation. So what I'm going to do is subtract 9x or add negative 9x. It's the same process there to get rid of this 9x from the right-hand side, from the right-hand side. So what I do to one side, I do to the other side, and as a result of that, I get negative 9x. Because negative 9x plus y, this is a positive y, equals, and when I subtract the 9x from the right-hand side, I have 0. Now this equation is in standard form. Negative 9 is the coefficient of x, 1 is the coefficient of y, because there's nothing there, and 0 is the constant number on the right-hand side. That's our value of c. This equation is now in standard form. Number 3 is a little bit different than the first two because we're dealing with a fraction now. We have to get rid of a fraction because, again, we want to deal with integer coefficients. So we're going to want to change this fraction into an integer. And how we're going to go about doing that is multiplying the entire equation by 3. And the reason I'm going to multiply the entire equation by 3 is because that will eliminate this 3 in the denominator. Because 3 times 2/3 is 2. 3 times 2 is 6. 6 divided by 3 is 2. That eliminates that. But I can't just multiply this by 3. I have to multiply everything in the equation by 3, which is why I see a 3 here and a 3 here. If I just multiply this by 3, then I'm just changing that number, and that doesn't make any sense to just change one part of an equation. You have to change everything by the same scale. So in doing that, I get 3y, because 3 times y is 3y. The 3 times the 2/3 x is 2x. Because 3 times 2 is 6, 6 divided by 3 is 2, and then the 21 comes from 7 times 3. This equation is not in standard form because x and y are not on the same side of the equation, so the next thing I'm going to do here is subtract 2, or add negative 2x. Do that on the right-hand side, do that on the left-hand side, and as a result of that, I get negative 2x plus 3y, it's positive 3y, negative 2x plus 3y equals 21, which is right there, and that equation is in standard form. Number 4, we're dealing with the same kind of thing. We have a couple fractions here, so we got to get rid of the fraction. We look at the denominators and see that they're both 5. So we're going to multiply this entire equation by 5. That will eliminate the 5's in the denominator. 5 times negative 3/5 is negative 3. 5 times negative 3 is negative 15. Negative 15 divided by 5 is negative 3. 5 times 8 is 40. Divided by 5 is 8. So this is the resulting equation we get when we multiply everything by 5 to eliminate those fractions. 5y comes from 5 times y. Negative 3x comes from this multiplication here. And 8 comes from this multiplication right here. Not in standard form because x and y are not on the same side of the equation, so I'm going to add 3x to both sides to get x and y on the same side of the equation. And I will get 3x plus 5y equals 8. 8 is right here. The 3x's are gone because I added the 3x to make it go to the left-hand side. And I have 3x plus 5y equals 8. Our coefficient here is 3. Coefficient here is 5. Coefficient here is 8. That is in standard form. So that's changing an equation from, in this case, slope-intercept form to standard form, just by using our processes of algebra there. The other thing we can do with standard form is graph the equations. And the one nice thing, really the only nice thing about standard form, is that you can find the x and y intercepts relatively easily. But we have to know a couple things about the x and y intercepts first. We have to know that the x-intercept, if we're talking about the x-intercept of an equation, an x-intercept is along the x-axis. And wherever the x-intercept is, the y value is automatically 0. That's what makes it an x-intercept, which is why I have a 0 installed here. So if I want to find the x-intercept of this equation, well, I already know that the y value has to be 0. So I'm just going to plug in 0 in for y, because if I'm looking for the x-intercept, the y value has to be 0, because that's what makes the x-intercept the x-intercept. And if I do 5 times 0, I get 0. So I can plug in a 5 right here, because 2 times 5 is equal to 10. I can kind of just pretend this 5y is gone, because when I multiply 5 by 0, I get 0. So then I have to answer the question, well, 2 times what gives me 10? That answer is 5. So the x-intercept of this equation is 5. And then if I want to find the y-intercept of that equation, I know that the x value has to be 0, because the y-intercept is going to be along the y-axis, and no matter where I am on the y-axis, the x value is 0. So I'm going to plug in 0 in for x once I plot my x-intercept there. Now I'm going to plug in plug in 0 for the x value to find the y-intercept. So now 2 times 0, this becomes 0, so this goes away. And now I have 5 times what gives me 10? Well, 5 times 2 gives me 10, so therefore 2 must be the y-intercept. And I can plot that point right here and draw the line that connects those two. And this right here is the line for the equation 2x plus 5y equals 10. Any pair of points on this red line will satisfy this equation. And I did that by finding the x and y intercepts. Same kind of deal over here with number 2. I have x minus y equals 3. If I'm looking for the x-intercept, I know the y value has to be 0, because that's what makes the x-intercept the x-intercept. So plug in 0 in for y. So what minus 0 gives us 3? That would be 3. 3 minus 0 is 3. So the x-intercept is 3. So we can plot the x-intercept right there. The y-intercept, looking for that, we know the x value has to be 0. So we have 0 minus what gives us 3. I have to think about that one for just a minute, because the obvious answer might be 3, but 0 minus 3 is not positive 3. 0 minus 3 is negative 3. So that would be a negative 3 in for y, because 0 minus negative 3 is positive 3. So our y-intercept is negative 3, which we'll plot right here. And we can draw the line that connects those 2 points, and this is the line for this equation. Any pair of points on this red line that I pick, and if I plug them into this equation, it will make sense. So that is changing equations from one form of an equation into standard form, and taking equations in standard form and graphing them.